Welcome back. In the last episode, we explored attributes and functions of BeautifulSoup, which aids exploring and extracting data from web page structures. We used dummy HTML text to demonstrate various approaches and constructs to show the BeautifulSoup capabilities in navigating web page structures and extracting data from it. We will take this further in this episode. We'll put our knowledge to test by exploring and navigating the structure of a live website. We'll aim to extract, to clean and organize useful data from this website with the power of BeautifulSoup objects. So if you find this content valuable, please subscribe to our channel, like our videos, and share with anyone who might benefit from it. Your support will help us to do more and share impactful knowledge through accessible means like this. So if you are ready, let's jump into JupyterLab editor to start scraping data from websites with BeautifulSoup constructs to gather the data, clean them, and present them in a more useful and informative manner. So in the last episode, we explored this HTML structure that is assigned to a text variable in Python, and we use BeautifulSoup attributes and functions to navigate through this HTML structure and illustrate extraction of data from such HTML structure, which is an example of the text structure we get when we extract web pages with BeautifulSoup object. So in this episode, we will use the knowledge that we gathered in the previous episode to explore this web page, which is a live and production web page. So this web page provides summary of information on investors selected by Innovate UK as a pool of investor partners. So this is a website provided by Innovate UK, and they actually arrange link to each of the investor partner in their website. If you look at this, each of these widgets are linked to investor partners, are links to description of investor partners, which is on their own page. If we click this, you can see the description of 24A Market Limited, the description of what they invest and how much they invest on this page, which is hosted by Innovate UK. But on their description page, on each of the investor partners description page, we can find specific information about the investor partner. For example, you can get their URL, the URL to the specific site of the investor partner. If we click this now, you go to the exact site for 24A Market from the description page of Innovate UK. So apart from that, you can get the contact. For example, this contact person, you can get the email of the contact person of this particular investor partner. So these are the kind of data we want to gather, we want to extract, and we want to automate the extraction all over the list of investor partners that we have in this Innovate UK website. You can see that in this first page alone, we have 1, 2, 3, 4, 5, 6, 7, 21 investor partners, and you can see that we can navigate these pages to page 2. And also there are a list of investor partners in page 2 in the same Innovate UK repository, and you can go down and down till page 6. You can see, let's click page 6 here, and this is the last page on Innovate UK where we have the investor partner. So what we want to do is to get the same kind of information for each investor partner and automate how this is extracted on the Innovate UK page, and that's what we want to achieve in this episode. So to start with, the first thing we need to do, we should remember from the last episode, is to import the request library. We need the request library because this is a live website, so we'll have to make HTTP request to get the structure of that website. After importing the requests library, we will need also the BeautifulSoup library. From the BS4 we will import the BeautifulSoup library. So if we have this import ready, let's create a function that we'll be using to actually extract our BeautifulSoup object. Let's say let's call it web extract. So we need the argument, the URL of the website. Then we make HTTP request, assign that HTTP request to a variable response, requests.get the URL as the argument. Then let's declare variable soup. So we have soup and we assigned none to it initially. Then we want to check now if our HTTP request is successful. Check if HTTP request is successful. Checking that, we need to check the response variable and check the status code of the response. So the status code, if the status code of the response is 200, this is the status code of a successful HTTP request. There's the status code of successful HTTP request. So if this is equal to 200, remember, and if this is true, we want to now get the BeautifulSoup object of that web page text structure, BeautifulSoup. Then two argument to this function is response. The HTML text structure that we get from the response, and we pass it with HTML parser. So this is done successfully. We want to signal this by printing website successfully retrieved. So this signals that this is successfully carried out. So else if there is any issue with the HTTP requests, so we want to get what happens, we want to print what actually happens. We signal first that there is a fail to retrieve the web page. Then we want to get the status code to actually know what went wrong. So that will be the response status code. So this will print this, signal us that there is a failed HTTP request, and give us the status codes to actually investigate what happened. So if everything is done, then we return the soup. So if it fails, that means the return will be none. But if it does not fail, then we have the return with the structure, the HTML structure of the web page that we request through its URL. Now we have the function that can get as an input, as an argument, the URL of any website that we want to extract, and it will return the soup structure, the soup which contains the HTML structure of the URL for us. Let's try this with the website that we have here to explore in this tutorial. Let's look at this. So let's say soup is equal to, so we will use this URL which we call the base URL. Let's assign this as a base URL. So we call this base URL and run. So we now want to make this an argument to the function that we've just written, argument to the function, and bravo, it says website successfully retrieved. Let's look at the structure of this. Let's say print soup.prettify. So this gives us a nice structured, nice looking structure of the web page, showing the hierarchy of the tags within the HTML web page. Let's look at this. Can you see? So we have the structure of the web page. You can see the structure of the website. So this gives us the structure of the website, which we can see here. and this gives us something that we can explore with BeautifulSoup attributes and function to actually extract data from the website. As we can see, this is so much. It contains a lot of jargons that we need to determine what exactly do we want from this data garbage. So if we look at this web page, the base web page that we are exploring, it has a list of investor partner that is arranged in this format. So what we actually need first is to determine, to get the link, the link on this web page that represent, that describe each of the investor partner. For example, if I click this, I will see this link goes to the description of 24 Haymarkets on this web page, and if I click this one, this the link will go to the description of the Act venture partner on this website. So we want to look at possibility of getting each of this link that leads to individual description of investor partner on this website. So we want to get each of the link that leads to individual investor partner. And one thing we should think about, if we are aware, if we know a lot about something about HTML, we know that within this, that means there is a tag that actually hosts the link to the description page, the a tag that holds the link to the description page. So what we want to actually look at and explore now is to get the list of a tags that link to each of the description page. That is the first assignment that we want to do here. So my first idea to explore this is, you can see that if we click this link, we will get to the 24 Haymarket Limited description page. So this that gets us to this description page is actually hosted within a tag, and is the href attribute is assigned to the href attribute within an h tag. So we want to look at the specific a tag that is hosting this link to the first investor partner description page. So we want to look at the a tag that is hosting the link to Haymarket Limited. Let's look at Haymarket. Let's call it Haymarket a tag. So we want to find within the soup the a tag that is actually that has the attribute, which is equal to href. Its href attribute, and assigned to it is the link to Haymarket Limited. So if we run this now, we should have that tag within the soup that is having the link to the Haymarket Limited. Let's print this tag. You can see now this is the tag. So we can see this is Haymarket Limited href, which is Haymarket Limited. So you can see this is the tag, this is the a tag that is hosting the link to that first investor partner description page. So one thing I want us to look at in this a tag is the class of the a tag, which is assigned, the class that is assigned to the a tag. Let's look at attributes of the a tag. So we have this attribute of the a tag, we have the class, and we have the href. We have the class and we have the href. My thought is that all the tags that is hosting the investor partners link might have the same class attribute. All the tags that is hosting the investor partners link might have all the same class attributes. So let's look at all a tag that has this class attribute within this soup structure. So to search for the target class within the soup, the a tag within the soup, let's first of all assign the class that we're looking for to a variable. Let's call it target class variable. Then we assign the class we're looking for. We're looking for the a tag that has this class as their attribute. So we can now say target a tags, target a tags. Let's use list complement. It will be tag for tag in soup.findAll, find all a tags. So this will be if there is a class attribute. If the tag has a class attribute at all, if class is in tag.attributes, and if tag.attributes, the class attribute of that tag is actually equals to the target class we're looking for, is equal to the target class we're looking for. So this list actually gets all the tag in the soup and look for the tag that has attribute class. Also, the tag that particular attribute class is equal to the target class. Let's run this. If we run this, it will give us the attributes of tags. Tag A, list of A tag that has this class attribute that we're looking for. Then let's say for tag in target tags, in target A tag, let's look for that, and let's print the tag. Let's print the tag. So we have all the tags that has the class. We have all the tag that has the class. So we can see some partner investor there. So to make sure that we are to actually look for the link within that A tag, let's do this. To look for the link with the A tag, let's say tag.gethref, tag.gethref. So we get all the href within this target A tag. Fine. This gives us the href. We can see now. Let's see. So the first one is 24A Market Limited. So the first one here is 24A Market Limited. The next one is Act Ventures. The next one is Act Ventures. Can you see? The next one is ADA. So we actually correct that all the tags that host this investor list are actually, they are all have the same class. So we first of all get the tags, all the tags that has this class, and we get the href within the tag that has this class. And if we're clicking this, this goes to 24A Market Limited link. It should, can you see? And the next link will go to Ventures. As they are listed on this, we have been able to extract the link to each of the investor partners in this base page of UK Innovate. You can see how we did it. We looked for A tags. We first of all looked for the first one. We get the first one, and we get the A tag that hosts the first link to the first investor partner. We look at the attribute of this A tag, and we see that the class is this, and we think that maybe the same class, all the A tags that have the investor partners in there as their href as the same class. Then we look for all the tags that has this class. From all the tags that has this class, we look for each tag within it and get the href of each tag. Then we can verify that all those tags are the ones that is hosting the link to the list of investor partners in that first page. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And if we go to the base page, you can see this is 3, 6, 9, 12, 15, 18, 21 in the first page. That is great. We have been able to explore that and been able to get the link to each investor partner description page here. So let's bring this together into a function that we can just call and give us this list of description link to each of the partners, list of link to the description page of each of the partners on the UK Innovate web page. So let's call this function def get description link. Let's get description page link, and this will take the URL and the target class, So we'll first of all use this to get the soup. We use this function to get the soup. So the soup will be equals to this function, and the argument will be the entered URL. And within the function, we want to have the set of tags: a tag, target, a tag, which is, we use list comprehension, so this will be tag for tag in the soup.find all a tags, find all a tags. So if this tag if class attributes is in the tag attributes, and the tag's class attribute itself, so the tag's class attribute is equal to the target class that we have as the second argument. So that's what we have here. Let me see if everything is fine. So we want to do this. We want to return a list, href list, which we can use also list comprehension. So we have href list is going to be href in for tag dot get href, right, for tags, for tag in target tag that we've got here, for tag in target tag that we've got here, for all tag in target tags that we've got here, and we want to return, we return the href list. So this is a function that will do this for us. Let's test it. The href list is equal to this function. Then we have the base URL. We have the base URL as the first argument, and we have the target class. We have the target class as the second argument. This should give us the list. Website successfully retrieved. That is from this soup that we first of all extract. So we can say HRE list. Let's say for ref in HRE list, let's print the ref. It should give us all the link to the description, to the investor partner description pages. Good. So we have the function that we can use to retrieve all those links. There is an error. There is an error that can occur with this function, but I will wait till when it occurs so that I can show you how to correct it. So now we can extract the pages, the link to all this investor partner description page. So to all the investor partner description page, which is the first thing we need to do so that we can access each of the investor partner page to extract individual data or information from this page. So we've got the function for extraction of this, but one thing that I want to notice is that, you know, this first page contains just 21, and we have the pages from 1 to page 6, which contains list of investor partners also. How do we navigate from the page 1 to the last page to ensure that we have extracted all links to the description page that is hosted on this Innovate UK website. This will require some form of intuition. When you look at this web page, let's go down to the next. You can see we have this next link that if you click this next from the base page, if you click this next, you will go to the page 2. You can click this 2 to get to page 2, or you click next. If I click next, it goes to page 2 of this web site. Then we have the list of another list of investor partner here. You can as well also from this first page, you can click the page 2 itself. So what the idea here is that from the first page, in this next link, we will have the link to the second page. When you click this next, we get to the second page, and when we are in the second page, if you click next, you get to the third page. So for at each of this page, this next link will contain the reference, the link to the next page. So at the first page, this next link will contain the link to the second page. When you get to the second page, there is still also the next link. This next link will contain the link to the third page, until when you get to the 6th page, which is the last page here, you can see that we don't have the next link anymore. So this is the idea, this is the concept we will use to navigate all these pages to get the link to each of the pages where they have the investor partner listed like this. So how do we get where this next link is in our BeautifulSoup structure? How do we get where this next link is? So we can see the next link, the text that we have in this link reference. If you have the idea of HTML, you know that this is going to be embedded in an A tag, and it will have an href. The href will contain the link to the next page. So from the first page here, this particular next will be embedded in an A tag, and it will contain the link to the second page. At the second page, the next there will contain the link to the third page. Let's use this idea, this solution, to actually explore and navigate the page and get the link. So the first thing we want to do now is to get the A tag from the base page. From the first page, we want to get the A tag that has that next link, that has the next text in it. So let me illustrate this idea one by one. First of all, we want to find all A tags in the soup. So we say all A tags, all A tags in the soup will be soup.find all A tags. So and from this A tag, we have a target. Let's say we have a target which we can assign none to initially, and we say for tags in this all A tags, we are looking for a particular tag if this tag dot text is equal to this the next text that we are searching for with the forward arrow. If the text is this, then we want to say assign this tag to the target tag. Assign this tag to the target tag and break out of the for loop. If we run this now, we should have the tag that contains the next inside this target tag. And you can see we have this. We can get the URL, next URL. Let's say next URL will now be the target tag dot get href. If I run this now and I print, next URL will be the next URL from the soup structure that we start from. So this is going to be the next URL, and looking at this URL now, we can insert it. We can put this as the base URL. Now if this becomes the base URL, then we say href list 2, and if this become the base URL, so it should extract for us the list, all the investors list, link to the investors page on the page 2. So the list of the link to the description page in the next page of the Innovate UK website. So let's run this now. If we run this and let's let's print this list. Let's view this list. You can see the list now. We have carbon 13 as the first. Let's go to the second page. From the first page, let's look at the second page. We explore starting from the first page, and the second page, let's look at what we have. So the first thing in the second page is carbon 13, and the second one is Catapult Ventures. You can see the second one is Catapult Ventures. So we are able to explore and get those links to the description page of all the investors list in the second page. That's how we will use, that's what we will use to navigate all the page to the last page, which I will write a function for it now. So to start with, let me change this construct, this two, that let me copy it here, control. So all this, I want to change all this into a single lambda function, So this will give us, so I want to comment this. So I just want to show you what I turns to the single lambda function. This will be our target URL. Next, let's say next URL is equal to soup.find now, and we want to have a lambda function which has argument tag, and the tag we were looking for, where the tag name is equal to a, and the tag.text is equal to next, and the forward arrow function. And all this, we want to actually get the URL href for this, so we want to get href. So that statement up to this stage, all the statements and including this also has been embedded into this single lambda function. So if I run this now and I print next URL, print next URL, this should give me what we have. So this, everything here has been to a single lambda function. So now I want to write a function that will return to us each next page of every soup structure that is entered into it as the parameter. So for here now, we want to say we have a function def get next page, and here we will have the soup structure that we have in here, and now the next page will take the soup structure and find this. So if let's say return this, it will just return this. So if we can't get any page, return this. If we cannot get any page, any tag that has next, and that means this will return none. So it's like if we get it, it will return let's say after this, let's say we have if we get next URL, return next URL, right? Else return none. So even if we put the return straight here, we will have it that way. So we can run this, and if we run this and we have our soup structure in here, next URL, so we have a soup that we have extracted from the base URL here. So we want to get the next URL from that soup. So this is the soup entered here. If I run this, it should give us the next URL that we have been looking at since that has previously returned. Can you see? It gives us, so we have this function now that takes in any soup and give us the next URL. So how do we navigate each of this? Let's now write a function that will put all this together to navigate all the pages from page 1 to 6 and give us the link to the investor description page as we have in each page here. So let's call this function, what do we call this function? Def get all investors link this page recursively. I will use recursive method now. Then the URL, so this is the entry URL which will start from the base URL, and now we have the next one. I want to have the target class. Remember, the target class allow us to get each tag that has the link to the description page. So that's the target class entry. So let's have the target class here as argument to this function. Then the investors list. So let's start from there. And first of all, let me have the list. Let's call this one current list is equal to the list that we have here. We want to copy it to the current list. Copy. And the first thing we will do is to get the soup of the base URL. We want to get the soup of the base URL. We want to get the soup of the base URL. So we say soup. We know the function. We have a function here, web extract, right? So we want to get the soup structure, web extract. Then we have the URL entered here. We have that returns the soup structure for us, and we want to say it should get the list from that, the list of the, let's have a page number. Let's have an entry page number which will start with 1, and we want to print so that we can see which page is printing. Now we want to print format page number, right? And this is going to be, I want this to be joined to the report that comes next from this extraction. So, and if we extract this successfully, we want to say look for the list here. This will return the list of investors link on this first page, and I want to extend the current list extend by the list returned from this function, and the URL here will be this capital URL, and the will be target class that we entered here. So if we have this done for us correctly, then we want to go to the next page. So let's go to the next page. The next URL is equal to this function which gets next for us. Next URL is the function, and this will be the soup that we have here, right? The soup here. So to get the next URL for us, so we will now check if this next URL is there. If we get the next URL, then the page number here will be this next page, which is page is equal to page plus 1, and we will now recursively run this again. So in this next URL will be entered here, and the page number is the same, the target class is the same. Then the list here now will be the current list that we have in here. So if not, so this will return this for us. And next, if let's say else return the current list for us. That means if this next is returns none, that means we have come to the end of the page. If this next return none, so it will return none here if we can't find a text that is a tag that has this text. So this href does not return anything. So that's when we have else here, then it will return whatever we have in the current list. Let me run this. Let's hope to see if this list works, if this function works. So let's say we have this now, and compiled, let's say compiled list is equal to this function. Then the base URL, we start from the base URL that we have here. We have here the base URL, that's where we start from. Enter the base URL. So the first number, then the page number, let's say it's 1. Then the target class, we have explored and realized that this target class helps us to navigate to the A tag that contains the link, that contains the link to each of the investor on each page here. So that's the target class that we have defined. So this is the target class, and the investors list starts from empty list. So let's see if this works for us. Why? First page retrieved, second page retrieved, third page retrieved. Wow, good. The sixth page. Wow, there's a breakage here. How do we find why did this break? So let's see why this break. Get down here. It's a non-type object has no attribute get. So something is wrong. We've done something wrong here. So I think it's here. If we get to the stage, when we find this soup that has this next, at the last page, there will be no A tag that have this next text. That means this will return none, and we are now placing a function get on a value that is none. So instead of writing this, what we do here is this. So we are not getting a ref here. We want to say if this next, let's say this is next soup, that this next A tag, let's say next A tag, right? Next A tag, and we now say if we get this, if this exists, if next A tag exists, that's when we now get this HF. That's when we get href, right? And we have this dot get href, and we return, or let's say we just return this. And if we have this else, that means we can't get next A tag from here, then we'll return none. I think this should solve the case. So we will not be calling a get object on a none if there is no next A tag. If we've gotten to the last page, that means there will be no A tag that has this next. You can see from here, if we get to the 6th page, which is the last page, there is no next again. So it will not have A tag in here that has that next with the forward arrow. So it will return none here, and as we have called the get ref straight here, we will be calling the get ref on value none. So let's run this again, and let's see if this works. Good. Let me see if we break again. Good. That is great. We've been able. Look, so before we rejoice, let's see the compiled list anyway. Before we rejoice too much, print compiled list. Oh, this is too much. Let's watch it. Oh, let's see length of the compiled list. Length. So we have almost, length is 117. So we have 117 from page 1 to page 6. Let's iterate through it one by one and see. For link in this, so let's print each link for us, and we'll be able to view it better that way. So it starts from Haymarket. So from the first page you can see, that we have 24 Haymarket. Act next, you can see Act. ADA next, you can see ADA. Then Albion, you can see Albion. So we've gotten all this link from the first page to the 6th page, so we can actually go to the description link one by one. Using this link, we can go to the description link to explore the kind of data we want. We said this is a compiled list of all the investor description page on this UK Innovate website. So one thing I noticed from the output we have here, we can see that we are making two calls. We are making two calls to actually retrieve, to extract a soup object from the URL. So there's a call here to extract the soup object, and I think there's another call here. That's why we are getting website successfully retrieved. Let's look at this get description page link. I call this link. Let's look at this up here. Let me change this to link. So it takes in a URL and make a call again to extract the web into a BeautifulSoup structure. Instead of this, let's actually enter a soup. Let it takes in a soup, so that we don't have to make this call. This soup, we just do the findings that we have here. Let's run this, and down here this will not work anymore. Let me get this out. It will not work anymore. And so in this place, in this function, rather than having to put in the URL again, the soup that we have got here will just be what we will enter here, instead of having to put the URL and inside the get description this particular statement is recalled again. So that's why we're having these two outputs. So let's run this again, and let's try if nothing will not break, if nothing breaks. So let's look at this. Inside the recursive, where does this break? There's a break somewhere. Wow, tell us, is there any form? There's a break somewhere. Let's see what happens. URL current list. Let's go back here, extend. I think this is what we've done. Yeah, is there anywhere we have target class, and we have the soup description page, base URL here. Let's say we have the soup here. Does it work? No. So let's look at where the problem comes from. Description page link. I run this, and I run this. Description page link for us. I think maybe there's a place we have the link. So this will give us the list. This works. So okay, yeah, description page link. So this is, I think this is where the problem comes in. I've changed the spelling. So let's run this and try this again. Good. So instead of calling it twice, I've been able to solve that. So yes, so we have the function that can retrieve all the investor link to the investor description page. So we have extracted the link to each of these investor description page, and we can be able to look up and see some of the data or information about each of the investors through the link, and extract it with a BeautifulSoup object. We will be stopping here now. At least we've learned something. Then in the next episode, we'll look at each of this investor page and see what data and we can extract, and how we will use this beautiful structure concept to extract data from each of the description page of the investors on the UK Innovate website. So all the codes that we have used in this episode, well structured and well commented, can be downloaded from my GitHub. The link is below this video. You can download the script and see if you are making any mistake in your own code, and see how we have worked it, read through it, and even if you can improve on the codes. So you can download them with the link below this video. So in the next episode, we will delve deeper into exploring this website. We will visit each of the investor description page using the list that we have gathered and extract specific data about each investor. We'll compile this information and present it in a reusable format. So remember, if you find this content valuable, please subscribe to our channel, like our videos, and share them with anyone who might benefit. Your support helps us to continue to provide impactful knowledge through accessible medium like this.